Operating principle of circuit breaker. A circuit breaker is a switching and current interrupting device. It consists, essentially, of fixed and moving contacts, which are touching each other and carry the current under normal conditions, when circuit breaker is closed. When the circuit breaker is closed, the current carrying contacts, called the electrodes, engage each other under the pressure of a spring. During the normal operating condition, the circuit breaker can be opened or closed by a station operator for the purpose of switching and maintenance. To open the circuit breaker, only a small pressure is required to be applied on a trigger. Whenever a fault occurs on any part of the power system, the trip coils of the breaker get energized and the moving contacts are pulled apart by some mechanism, thus opening the circuit. The separation of current carrying contacts produces an arc. The current is thus able to continue until the discharge ceases. The production of arc not only delays the current interruption process, but it also generates enormous heat which may cause damage to the system or to the breaker itself. Therefore, the main problem in a circuit breaker is to extinguish the arc within the shortest possible time, so that heat generated by it may not reach a dangerous value. The basic construction of a circuit breaker requires the separation of contacts in an insulating fluid, which serves two functions. 1. Extinguishes the arc drawn between the contacts when the circuit breaker opens. 2. Provides insulation between the contacts and from each contact to earth. The insulating fluids commonly used for this purpose are as follows. 1. Air at atmospheric pressure. 2. Compressed air. 3. Oil-producing hydrogen for arc extinction. 4. Ultra-high vacuum. 5. Sulfur hexafluoride, SF6. The fluids used in circuit breakers should have the properties of high dielectric strength, non-inflammability, high thermal stability, arc extinguishing ability, chemical stability, and commercial availability at moderate cost. Of the simple gases, air is the cheapest and most widely used for circuit breaking. Hydrogen has better arc extinguishing property, but it has lower dielectric strength as compared to air. Also, if hydrogen is contaminated with air, it forms an explosive mixture. Nitrogen has similar properties as air. CO2 has almost the same dielectric strength as air but is a better arc extinguishing medium at moderate currents. Oxygen is a good extinguishing medium but is chemically active. SF6 has outstanding arc quenching properties and good dielectric strength. Of all these gases, S6 and air are used in commercial gas blast circuit breakers.